This lesson has to do with graphing absolute value functions, something that we have been insinuating we were going to do, and now we are actually going to dive into it. We have two goals for this lesson. The first goal is to basically write an absolute value function as a piecewise. Write an absolute value function as a piecewise. So you have to have a good mastery of piecewise functions, and if you have not completed the assignment for piecewise functions, I would pause this and go and complete that, because you're doing things out of order here, and this will not make a lot of sense. Your second goal is to then graph it and to show a visual representation of what an absolute value function means. So we're going to start with a basic example. Y is equal to the absolute value of x. You have many graphing tools that can graph this for you, but you need to know what this graph looks like by hand. If I do a basic t-chart, we can get a graph that looks a particular way. But I think you can reason through a couple of different options. For instance, you should have an idea that whenever x is positive, or we could say equal to 0, this graph is going to act like y equals x. When x is positive, the graph is going to basically look like y equals x, and y equals x looks like this. It looks like a graph with a 45-degree angle where every x and y point are the same. And this is essentially the graph of y is equal to x. So pretty basic on that. But then I get another situation where I can say what happens when x is negative. When x is negative, if I plug in negative x values, it's going to make the y values be positive. Well, something else that does that is the graph acts like the function y equals negative x. Basically, plugging in a negative x value will make the negative become positive, and y equals negative x looks like this. So this gives a very unique but characteristic V shape to a graph of an absolute value. And this graph is the graph of y equals negative x. We have a special name for this point here. You may have seen the name vertex, but I like to give this a better name. This is called a cusp. A cusp in math means an abrupt turning point, a turning point that could not be predicted by looking at either direction. So knowing that, we then get the piecewise graph. Could be y equals, I'm going to split it into two, and for the upper right area, this could be y equals x whenever x is greater than or equal to 0, and y equals negative x whenever x is less than 0. I could have just as easily taken this equal part and moved it down here, and it would have been fine. What I don't want is I don't want the equals to be on both of them, because that's just very poor notation for what a piecewise function does. There should be absolutely no overlap of any kind. Okay, so let's try another example and move into how this is going to end up looking. Starting with y equals the absolute value of 1/2 x minus 4, and then plus 6. So one of the ways that I think makes sense to do this is to try to get this to match a particular form that is going to make this easier. I want this to match the form of y is equal to a times the absolute value of x minus h plus k. I know that this doesn't make a lot of sense right now, but what it essentially means is that I want to factor this 1/2 out. I want to pull that 1/2 out of both of these, and if I factor it out of both of them inside the absolute value, I would get 1/2 times the quantity x minus 8, then plus 6. Well, I can now put this 1/2 into parentheses and put that kind of as a coefficient, because now this is the same thing as the absolute value of 1/2 times the absolute value of x minus h plus 6, or y is equal to 1/2 times the absolute value of x minus h plus 6. So what this does is it tells me that the cusp of this graph is going to be the value that I plug into this middle that's going to make that inside of the absolute value become 0. That cusp is going to occur at an x value of 8. When you plug 8 in, you get 0 times 1/2, you get 6 out. This tells me that the cusp is going to occur at 8, 6. So setting up a grid of this, drawing that grid out, I'm going to go right 8 and up 6. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6. That goes there. That is the location of the cusp. The cusp is at x equals 8 because that makes x minus 8, which is the thing inside the absolute value, be 0. Then I also figure out that when x does equal 8, y equals 6. So therefore there is a cusp at 8, 6. Then, to kind of examine this, I figure out that to the right of the cusp, whenever x is greater than 8, so when we're going to the right of the cusp, when x is greater than 8, basically the absolute value doesn't really do anything, so we have a slope of 1/2. I can tell that by looking at this equation right here. When x is greater than 8, we have a slope of 1/2. That is an up 1 over 2. I'm going to put a point there. That's kind of all I have the room for. When x is less than 8, well, when x is less than 8, plugging in negative numbers for x gives the same result as the positive number. So another way to think about that, well, I'm going to first write that we have a slope of negative 1/2, because the reason that that slope is negative 1/2 is that if I take this and split it into a piecewise function, so right of 8, I'm going to keep the 1/2 x minus 8 plus 6 whenever x is greater than, and I'm going to put the equals 8. But left of 8, I don't have absolute value anymore. So I need something to act like the absolute value, and what acts like the absolute value is the negative that makes the negative value become positive. Left of that, we have x is less than 8. Or left means x is less than 8. So then I go up and over, and I have the V shape going this way. I can put a few more points there, put a few half points, put a half point here, and then just kind of draw out and draw out that way. These V shapes will always be at the same angle to the left as they are to the right. They should be symmetric. So let's now take this piecewise that I've crafted here and simplify it. If I distribute the 1/2, I'm going to get 1/2 x minus 4 plus 6 is plus 2. And I get an x is greater than or equal to 8. And then negative 1/2 x plus 4 plus 6 will be plus 10. And x is less than 8. Now, if we look at these equations, they should match what we're seeing here and here. Like if I took this line and extended it all the way down, it would cross at x equals or y equals 2. And if I took the other one and kept it going up right here, that would be y equals 10. So the y-intercepts of those lines actually do match. And another way to figure out the equations of those lines is just to try to figure out, based on what you're graphing, what the equations are. Okay, let's do another one that's another exception to this and just looks a little different. Y equals negative 3, absolute value of negative 2x plus 1. So I was going to put that in parentheses, but I'll save that for the next step. Come on, erase my, it's not like me erasing right now. Okay, we'll put parentheses around that. Of course, it erased that one. Okay, I'm just going to put parentheses inside the absolute value. You know, you can stick those in if you want to. Because what I'm going to do now is inside this absolute value, I'm going to take out the negative 2. I'm going to factor the negative 2 out. So I get an x minus 1/2. Then I'm going to take the absolute value of negative 2, which comes out as a positive 2, and multiplies by that negative 3 to give me a negative 6. And I end up with absolute value of x minus 1 minus 4. This allows you to so much more easily figure this out. Then I'm going to identify where the cusp is. The x value that makes the inside become 0. That is 1/2. When you plug that in, 0 times negative 6 minus 4 gives me negative 4. Okay, that means that this particular shape is going to be pointed in a different direction because of the negative coefficient. It also means I want to get a grid down.
Well, I'm proud of you. I didn't think.
Okay. It definitely does not like these shapes right now. Okay, that's not good. Wonder if I can slightly scooch that up a little bit. That'll work for me. Not the greatest, but I can live with it. Pardon the issues here. But you guys can advocate for me to have a computer next year with more RAM. Okay, so we go 1/2 -4. I had previously said I'm okay with you graphing half points, so 1/2 -4 would be right here. And given that the cusp is at 1/2 -4, okay, now I'm going to go right to the piecewise. Whenever we are to the right of the cusp, it's really the same slope. So to the right of the cusp, we would have -6, x minus 1/2 minus 4. But then the left of the cusp should be the opposite of -6, +6, x minus 1/2 minus 4. Let's make that a piecewise. Y equals, we're going to distribute the -6, so -6x plus 3 minus 4 is -1. And whenever x is to the right of the cusp, let's be very clear that this is to the right of the cusp. The cusp is at x equals 1/2. And then when left of the cusp, 6x minus 3 minus 4 is -7. And x is less than 1/2. This is the piecewise. Then let's graph it. To the right of the cusp, we have a slope of -6. Couldn't have made this easy, could I? Let's just sketch and draw this line down a little bit further. Okay, so down 6, right 1 would actually put a point here. Then down 6, left 1 would actually put a point here. And this is just a very, very skinny downward shaped graph. Ooh, let's do one more. Y equals 1/2 absolute value of 4 minus x over 2 plus 1. I don't like the way that that's shaped and formulated, so I'm going to manipulate it to get it into a better form by making it -x over 2 plus 4 plus 1. I am going to factor the -1/2 out. -4 with a -1/2 factored out is like taking, or 4 with a -1/2 factored out is like taking 4 times -2, which gives me -8. And you can check that by multiplying the -1/2 back and making sure you get what you had before. The -1/2 comes out as a +1/2. The +1/2 multiplies by the existing 1/2, giving me y equals 1/4 absolute value of x minus 8 plus 1. That is the form that we want. Then we look at the cusp, not the cup, but the cusp. Cusp occurs at x equals 8, and when you plug in 8, you get 1 out for x, or for y. The piecewise, we're going to go to y equals, I'm going to write 1/4 parentheses x minus 8 plus 1, and then -1/4 x minus 8 plus 1. But it is very tempting for you to not put the domain restrictions to the right of that. So we have to put the comma. This is when x is to the right of 8, and this is when x is to the left of 8. That same 8 is the one that we use right there. Then we simplify. 1/4 x minus 2 plus 1 would be -1 whenever x is greater than or equal to 8. And then -1/4 x plus, plus 2 plus 1 would be plus 3. Then I'm going to go to the graph. I'm just going to sketch a grid here because I don't trust the tool right now. That wasn't too bad. 8, 1. Man, I get these really off the grid. Okay, I'm going to cheat. Let's see if it lets me erase that. It did. And I'm going to move that all the way down here. Try it one more time with a better line. There we go. Okay, then 8-1 is going to be like that. To the right of it, we have a slope of 1/4. So I'm going to put that point in with some half points. And then to the left, we just mirror that, negative 1/4 with the slope, with some half points. Then sketch to the right and sketch to the left. That was terrible, but that works. Keep practicing that. That's it.